All right. Good morning, everybody. Good morning, world.
Good morning.
Any questions on the videos that were assigned for today?
What videos?
Ooh, yeah. That's what I was expecting, kind of. So, instead, were there any questions on the multiple choice questions that were yours to do last night?
Last night.
Are they graded in
I haven't looked at them, but I imagine the grade is there. So you can look at it to see if you got any wrong. I planned for this, so we can look at some more problems unless people have questions. All right, let's go. That's going to be you should see something. Unit 9 examples or something. I forget what I called it. Yeah, Unit 9 examples. Go forth.
What is it?
Unit 9 examples. All right, question one. Question one. Take a look. Answer it if you dare. I don't want to know your answer yet. I want to know which answer or answers are wrong and why are they wrong.
I don't want you to go answer. I think B and C are wrong.
B and C, you both say this. Why?
Because a linear relationship can be negative or positive. So.
Negative, or a linear relationship could be negative or positive. Same idea. And it doesn't specify one or the other here? Okay. We're down to 3. More wrong answers?
A doesn't have like beta. It's just
Okay. Remember for like means, we would always have mu here. Like, if you were to see this, you would be like, why are there X bars? That makes no sense. This is a sample statistic. We don't need to make hypotheses about that. This is something we know. If we take a sample and fit a line to it, we know the slope of that line. That's B. Beta is for the population. Beta is what these hypotheses are about. So, yeah, I agree. 50-50. Which one's wrong? D? Why is D wrong? It just is.
The null hypothesis is what we're trying to prove. It's not right.
The null is what we're trying to prove?
Well, like how D is set up is basically the null is what we are trying to prove in the problem.
Oh, I see what you're saying. So for D, the null hypothesis is that the slope is not 0, which would suggest that there's a linear relationship. That's what we're trying to prove. But what we're trying to prove should be the alternative hypothesis. So this is backwards. I agree. Answer here is E. Yay! That's 1. You can see there are 6 problems here, and one of them is free response.
Oh.
I don't remember where I put it, so we'll see. Let's go to number 2.
It's not question 2.
It's not number 2.
This one is one.
I don't even got
Oh no, it's one of
That's
these.
a free response is going to be.
So,
When you read to yourself, do you hear your own voice talking?
Yeah.
yeah.
Is that how it works?
I don't know.
I don't know.
It
Just kinda, I just
It just
think the
depends.
words.
Sometimes yes, but a
You
lot of
know.
the time no.
Interesting.
Wait, that's kind of weird. I don't know. I just read
You know,
it.
you just made me read it in your voice, so thank you for that.
See, I
I
want to
know,
hack my
yes.
brain so that I hear like James Earl Jones's voice. or
Sometimes
Morgan
yeah,
Freeman.
it's like if you're talking to me, then that's who's reading it. There you go.
Alright. So we want to know which of these is an indication that the normality condition has been met. We're specifically looking at the normality condition here. So if any of these are true, they should relate to something being normal in shape. Okay. 1, a residual plot with no apparent pattern in the residuals. Is that an indication the normality condition has been met?
No.
No?
No.
What is that proof of?
Not
Random.
normality.
If there's no pattern in the residuals, then that means that when you fit the best fit line, then it's a good fit. That's the linearity condition. that the relationship is linear in shape. It has nothing to do with the normality of the residuals. So, yep.
So opposite.
So that restricts our options how?
It's not
It's
A.
B and D.
Wonderful.
So basically, is 3 right and is 3 wrong?
Okay, so we only have to check 3 at this point because we know 2 is good. And in fact, a histogram of the residuals that is centered at 0, unimodal, and symmetric, that's normal. Perfect. So what about 3?
No.
No?
No.
No? What tips you off there?
Because number 2 already talked about the
Wrongly
graph.
skewed.
Hey!
With
Hey,
outliers.
he's talking.
You're saying skewed with outliers?
2 was already saying it's unimodal and symmetric, and 3 was just like something different. And we know 2 is fine.
Yeah, so 2 and 3 couldn't possibly both be true because they're saying different things. Plus, if the residuals are skewed and have outliers, then those aren't things that we would expect for normality. So, no, B.
Sadly, we've reached the free response question.
Sadly, we have reached the free response question. Is that how you feel?
Yes.
After
Yes,
all
it
of the
does.
problems we've done in this class?
Yeah.
Yes, that is how I feel after all of the problems we have done in this class.
Pain, suffering.
I don't know what to say. I don't know what to say. We still have 4 weeks to get it together.
Okay, I found the free response.
Hey, look at all the reading you have to do. Have fun. I'll see you in a few. Anyone need more time to read the setup?
Number 4.
No, we're doing number 3 first.
All I have to say is,
Is your-
the last sentence kind of gives me, or like, not the last, but at the top, the data are given below.
Uh-huh.
That sounds wrong to me. Wouldn't it be the data is given below?
That's a hotly debated issue, whether data is singular or plural. Technically, the word data is plural because the singular is datum.
Data's.
Datum.
Channing datum?
Chaining datum. All right.
Datum? I
So-
don't even know.
Oh my gosh.
True.
So what we've got here are essentially 2 different populations. You've got a bunch of students who completed a PhD program and those who didn't. And what we are gathering, our 2 variables, are GPA and credit hours. And we're wondering if GPA essentially affects credit hours differently in these 2 populations. Could we take a student's undergraduate GPA? Is it their undergraduate GPA?
Yeah.
Okay. And predict how many credit hours they will take. And does that affect whether they will successfully complete the PhD program? Are they up to snuff, essentially? So part A wants us to use an appropriate graphical display to compare the GPAs for the 2 groups and to write a few sentences commenting on your display. We are not going to make that display, and I cannot believe this was a question on an AP test in the year 2010, because I imagine that would take some time. The thing is, what graphical display is appropriate for this data? Come on, you 1 semester prob stats people, when you have 2 variables, what's the appropriate graphical
Mason.
display? Was it?
Said Mason.
What about it?
Oh.
You took it too?
That was
Well, that was
why
10 years ago for
Mason
me.
was just in it.
When you did your project, what type of
Histogram.
graphical display?
I don't know.
Wasn't it history?
Scatterplot.
Scatterplot. We want to know the relationship between 2 variables. That's scatterplot territory. You didn't even take the class.
No, Mason said it and I just said it right after he
Oh.
took my answer.
Shame.
Hey, you didn't hear me. I just.
That's fine, I'll take the credit.
Does that mean I've just started tuning you out?
Probably.
Sorry. All right, so scatterplot is what we would make here, and you can see how long that might take you to do. You would have to scale both your axes, plot every single point. To be fair, this is an investigative task. That's number 6 of the free response questions, so I think you're allotted 25 minutes for this problem. That's probably gonna be the lion's share of it, just making the scatterplot, and that's ridiculous. So we're just gonna pretend that we did that.
Okay.
And move to
Maybe
part
test.
B.
I'm not pretend I did all that.
Move to part B. For the students who successfully completed the PhD program, is there a significant relationship between GPA and the mean number of credit hours per semester? Give a statistical justification to support your response. Okay. So we're only looking at those who completed the PhD program. So that's this output. Okay. Yesterday we looked at some regression output, and we know that constant refers to the what part of the
line.
regression line?
The one thing where
That one.
I know it's like
The,
I don't know what it's called, but like I know what we're trying to
Your
say.
Algebra 1 teachers are just so unhappy right now.
Because
Mr. Winwood
Why are
really.
no, because I know it's the line. It's
Constant's
one.
there.
It's the line. I just don't know what that line is called. It's over.
I'm so
Y-intercept.
confused.
The y-intercept. Hey.
I said that!
Unreal.
Oh.
So we are ignoring this row. We don't care anything about the y-intercept really. It's really GPA is the dependent variable here.
Yes, sir.
You guys are too much.
Yes, sir.
We know coef is the coefficient. So for example, we could build the regression line here. We could say we're predicting the credit hours here. We could say hours hat, because we're predicting the number of credit hours, is equal to 23.514 minus 2.7555 times GPA. Okay, that's a skill that could be useful, is building that regression line. And this is for successful. Okay. This is the standard deviation. Well, it should say standard error, right? This is the standard error of the slope. We have new columns here, T and P. T is the test statistic. They've done the test for you. Okay? And P is the p-value.
Aw.
How about that?
Because I'm not doing that.
This is why it's one of the reasons that I gave you the videos from College Board rather than going through things the way I did for all the other units. Because I would have gone through how to do the test, whereas usually for regression, they're just going to give you this table. You don't have to do the test, usually. Okay. So we want to know if there's a significant relationship between GPA and credit hours. Well,
Wouldn't we just look at the p-value?
when we just look at the p-value,
0.
it's pretty much 0. Maybe it's really, really small. It just rounds to 0 for 3 decibels. What would the hypotheses be here for this test? That might be useful to know.
There's no relationship between GPA and credit hours.
Which hypothesis is that?
No.
That there's no relationship? And how would we write that in terms of a parameter? Maybe you want to go back to one of the multiple choice questions we just did that had those hypotheses. Beta equals 0. Okay. That would suggest that the true regression line for that scatter plot is a horizontal line. If the slope is 0, then there's no relationship. Whereas the alternative would be, yeah, beta not equal to 0. And that would suggest there is a relationship. I think it's important to have those hypotheses because now we look at the p-value, see that it's approximately 0.
There's certainty that they are related, or more or less certainty.
There's strong evidence that there's a relationship.
Big evidence.
Because with that p-value, super small, definitely less than whatever alpha would be, 0.05, it's smaller than 0.05. So we would reject the null hypothesis and conclude that there's evidence of the alternative. There's strong evidence. So part B, is there a significant relationship? Yes. Because the p-value is less than 0.05 or whatever alpha is. Did it say alpha anywhere for the significance level? I don't feel like it did. Nope. So we can just assume it's 0.05. Give a statistical justification to support your response. It's right there. So for part A, you might just put scatter plot. Write a few sentences commenting on your display. That's hard to do without doing it. So you can just say scatter plot there. I'm cool with that. Any plans of attack for determining whether this student is going to be able to cut it in grad school?
I mean, probably.
Evidence?
I looked at the table and there's some really similar values.
Specifics?
There's one that's like 3.5 and 14.5 credit hours.
Yeah.
Sorry, what numbers?
13, or 3.5,
top
14.5
Oh, up here.
on the
So you're trying to use the original values and try and find someone that's close to this student?
there's some stuff.
Yep.
Okay. I suppose you could do that. I would argue that we want to be able to use the entirety of the sample.
Why not do it?
I appreciate your honesty. Maybe we could use this student's information. And then based on these lines, we could figure out how far away from the predicted line they are. Does that seem reasonable?
I like my way.
Because you've got a line for the successful people. You're going to have a different line for the unsuccessful people. They're probably going to have different slopes, different y-intercepts. And we can plot this point on there and see how far away it is from each of those lines. And whichever line it's closer to, that's probably where they belong. Does that make sense? How can we figure out how far away this student is from, say, this line?
Put the GPA in there.
Essentially, I want to calculate this student's residual.
Can you put the data in up into that equation?
Which,
Like you put the hours and where the hours are at, and the GPA where the GPA is at?
if I do that, it's probably not going to give me stuff that equals.
Okay.
That's a good call, though.
Something like that.
We are going to want to plug in either the GPA value or the hours value, but not both. What is it we're using this line to predict? The hours. We're using GPA to predict the number of credit hours they're going to take. The line is predicting the hours, so which should we be plugging in?
GPA.
The GPA. Based on the student's GPA, this line is telling us how many hours we would predict them to take. We're going to compare that number to the hours they are taking and see how far away those are. Okay, so we're plugging in 3.5 here. You can do that. Do we have our predicted number of hours?
Yeah.
Uh-huh.
13.87.
13.87. So for a student with a 3.5 GPA, the successful ones, we would predict their number of credit hours to be 13.87. How many credit hours are they actually taking?
14.5.
What's the difference? We take the actual minus the predicted. 0.13? That seems pretty close. Whoop, 0.13. I want to see if you can do the same thing for this line. Find the equation of the regression line, plug in your GPA of 3.5, find the residual. I don't want the answer, but does anyone have the residual for the second one?
Yeah.
Yeah. Can I get the regression line equation?
24.200
The whole regression equation.
Yeah.
hours hat
Thank you.
is equal to 24.200 minus 3.485 times GPA.
Okay. And we're plugging in 3.5 here again. So if not successful, and what is the predicted value for hours?
Well, 20, 0, 0, 0, or 0, 0, 2,
So pretty much 12.
just 12, yeah.
12. 12. Okay, again, this student had 14. So if we want the residual, is that 14 minus 12 or 12 minus 14?
14 minus 12.
14 minus 12, the predicted value goes second. The residual equals 2. So what say you? Is this student going to be successful in their PhD program?
Yes.
We would suggest there is evidence, yes, because
The residual is closer to the line of successful than the non-successful.
smaller residual means that this student is closer to the line for successful rather than not successful. That would be your justification. Type it in. We're good for today. Good work. I still want you to watch the videos, but you can see you don't necessarily need to, as long as you take good notes here. So I think the last 2 videos are scheduled for tomorrow, so if you are keeping up with those, you'll probably just see some additional examples, I think, in those 2 videos of tests, and then a review of all the different inference methods. I will probably be adding some more problems here to this review for tomorrow. That'll be our last day in Unit 9. You'll have the rest of the week to work through whatever you need to do. There are more assignments coming due. Your unit test will be Friday. Bye.